Alright, we got to figure out what's u here to integrate it. If I make this u, usually the piece inside of something, when you drive it, you don't get this. But when you drive this, you don't get that either. So neither one really works well. So let's choose the one that's inside. And you'll see something actually working out in a second here. So let's say u equals 2 minus x. That means that du is equal to negative 1 dx. That still doesn't help too much because dx replaces with du, or negative du, because it's negative. But don't we still have this x plus 1 sitting out here? This becomes a square root u, but I can't get rid of that x. But I can. Here's where the trick comes in. Look at this right here. Let's rewrite that. U equals 2 minus x. Can I solve this for x? Take my equation. If I solve that for x. So let's solve it for x. Do you understand? You like minus the 2 over. Do you understand when you solve this for x, you're going to end up with x equals, you minus the 2 over. It's going to become 2 minus u. If you solve this for x, you get x equals 2 minus u. I skipped some steps, but are we okay with that? Now watch this. We're going to do all this sorts of substitution here. Here we go. X plus 1. Instead of x, can I replace this right here for x? So I can replace 2 minus u plus 1. Okay? I replaced the x with a u. Alrighty, next, isn't this going to be square root u? Because isn't u 2 minus x? And then, real quick, we forgot this. Don't we have to divide by negative 1 here? So we have negative du equals dx. So when we take this dx and replace that dx, so won't that leave us in the end a negative 1 dx? Thank you. Du. Now is everything in terms of u's? Is that integrable? Not yet, but look, watch carefully. Watch what happens here. Can I combine what's inside of this parenthesis right here? Can I combine all that? Don't you have 3 minus u? And can't I rewrite this as u to the 1/2? And can I take this negative, bring it out front, and have my du? Now, some of you say that doesn't help at all, but can anybody see what happens here? Can't you FOIL or distribute that? And what I now have is I now have 3 u to the 1/2 minus u to the 3/2 du. And can you integrate that now? Yes. So let's restart from here to here. This is where this is integrable now. We can do this. Again, we found u. That didn't help us too much. So what we did is we took u and solved it for x. And then we replaced all our x's with that. Then we plugged it all in and we did some distributing and we got something we can use. It is kind of weird. It is takes some time getting used to. This is the hardest of the types of u substitutions because you have like a u and an x. You have to both deal with both. Okay. So now we integrate this, so it's simply going to be negative 1, and that's in front. And this is going to be 3, and this, when you integrate it, becomes 3 over 2, which becomes u to the 1/3. And not, oh, the 3 disappears. Do you understand there's going to be 2 there? Because it doesn't become 3 over 2, and when you divide it, the 3's cancel, leaving the 2 on top. So I skipped some steps. When you add 1 to 3 over 2, don't you get 5 over 2? Okay? Let's distribute the negative and plug in the u. So we now have negative 2. And u, what was u again? It was 2 minus x. This becomes a plus. And the 5 over 2, and this is a 5 plus c. Now that is your answer, but just real quick, if it's a multiple choice test, could you pull out a 2 minus x 3 to the 3/2 power, a GCF of that? You technically could. I'm just pointing out you could do that. Don't worry about it, but I'm just pointing out that you want to look for GCFs if it's a multiple choice test. That is good enough.